So just a brief introduction. It has been some time since I have been able to do any microcontroller or electronics type of learning, and that's because of my sanitation job, which has got me pretty beat. So here is my LCD video on my channel. If all goes well, after I record this video on the data sheet, I will actually put it as an unlisted video in the description below. I realize this is ambitious because there are 60 pages, so that's going to take a lot of 5-minute videos. So maybe I will read quickly. Here we go. HD44780U dot matrix liquid crystal display controller driver Hitachi. Description: the HD44780U dot matrix liquid crystal display controller and driver LSI displays alphanumerics, Japanese kana characters, and symbols. It can be configured to drive a dot matrix liquid crystal display under the control of a 4 or 8-bit microprocessor. Since all the functions such as display, RAM, character generator, and liquid crystal driver required for driving a dot matrix liquid crystal display are internally provided on one chip, a minimal system can be interfaced with this controller driver. A single HD44780U can display up to one 8-character line or two 8-character lines. The HD44780U has pin function compatibility with the HD44780S, which allows the user to easily replace an LCD2 with an HD44780U. The HD44780U character generator, ROM, is extended to generate 208 5x8 dot character fonts and 32 5x10 dot character fonts for a total of 240 different character fonts. The low power supply, 2.7 volts to 5.5 volts of the HD44780U, is suitable for any portable battery-driven product requiring low power dissipation. Features: 5x8 and 5x10 dot matrix possible, low power operation support, 2.7 to 5.5 volts, wide range of liquid crystal display driver power, 3 to 11 volts, liquid crystal driver waveform, A, one-line frequency AC waveform, correspond to high-speed MPU bus interface, 2 MHz when VCC equals 5 volts, 4-bit or 8-bit MPU interface enabled, 80 by 8-bit display RAM, 80 characters max, 9920-bit character generator ROM for a total of 240 character fonts, 208 character fonts 5x8 dot, 32 character fonts 5x10 dot, 64 by 8-bit character generator RAM, 8 character fonts 5x8 dot, 4 character fonts 5x10 dot, 16 common X40 segment liquid crystal display driver, programmable duty cycles, an 1/8 for one line of 5x8 dots with cursor, 1 divided by 11 for one line of 5x10 dots with cursor, 1/16 for two lines of 5x8 dots with cursor. Wide range of instruction functions: display clear, cursor home, display on off, cursor on off display, character blink, cursor shift, display shift, pin function compatibility with pin function compatibility with HD44780S automatic reset circuit that initializes the controller driver after power on, internal oscillator with external resistors, low power consumption, ordering information, different types. No, I won't read them. CG-ROM, Japanese standard format, European standard format, custom font. And here is a block diagram. I can zoom out 100%. Okay, is it worth reading all of this? MPU interface, input-output buffer, instruction register, instruction decoder, timing generator, display data RAM, DDRAM, 16-bit shift register, common signal driver, address counter, data register, busy flag, 40-bit shift register, 40-bit latch circuit, segment signal driver, LCD drive voltage selector, character generator, RAM, CG-RAM 64 bytes, character generator, ROM, CG-ROM 9920 bits, cursor and blink control, parallel serial converter, and attribute circuit. And pin arrangement, FP80B. And here's the 80F, whatever these are. The 780U. Pad location coordinates. Pin functions. Note to self to timestamp this. Pin functions. Signal RS. Number of lines 1. Input output I. Device interfaced with MPU, maybe microprocessor. Function selects registers. 0. Instruction register for write. Busy flag. Address counter for read. 1. Data register for read, for write and read. Read-write, number of lines 1. I/O. I guess that because it's like input-output and it's an input. Is that what that means? And these are both input-output and this is just output? Not sure. RW selects read or write. 0 is write, 1 is read. The enable pin, number of lines 1. Input, device interfaced with MPU, starts data read / write. DB4 to DB7, number of lines 4. Input output, both. Device interfaced with MPU. 4 high order bidirectional tri-state data bus pins used for data transfer and receive between the MPU and the HD44780U. DB7 can be used as a busy flag. DB0 to DB3. 4 lines, input output, for low order bidirectional tri-state data bus pins used for data transfer and receive between the MPU and HD44780U. 3 pins are not used during 4-bit operation. CL1, 1 line used, input output, output. device interfaced with extension driver, clock to latch serial data D sent to the extension driver. CL2, one line, output extension driver interfaced with clock to shift serial data D. Okay, pin functions M, one line is an output, functions with the extension driver, switch signal for converting the liquid crystal drive waveform to AC. D, again that's the signal, one line is an output, interfaced with the extension driver, character pattern data corresponding to each segment signal, COM1 to COM16, 16 lines, output, interfaced with the LCD, common signals that are not used are changed to non-selection waveforms. COM9 to COM16 are non-selection waveforms at 1/8 duty factor, and COM12 to COM16 are non-selection waveforms at 1/11 duty factor. Seg1 to Seg40, 40 lines, output, LCD, segment signals, V1 to V5, 5 lines, it's neither input nor output, power supply for LCD drive, VCC, 5 volts, 11 volts max, VCC ground, 2 lines, power supply, VCC, 2.7 volts to 5.5 volts, ground 0 volts. Oscillator 1, oscillator 2, 2 lines, not I/O. Oscillation register clock. When crystal oscillation is performed, a resistor must be connected externally. When the pin input is an external clock, it must be input to OSC1. Function description. Registers. The HD44780U has 2 8-bit registers, an instruction register, IR, and data register, DR. The IR stores instruction codes such as display, clear, cursor shift, and address information for display data RAM, DD-RAM, and character generator RAM, CG-RAM. The IR can only be written from the MPU. The DR temporarily stores data to be written into DD-RAM or CG-RAM and temporarily stores data to be read from DD-RAM or CG-RAM. Data written into the DR from the MPU is automatically written into the DD-RAM or CG-RAM by an internal operation. The DR is also used for data storage when reading data from DD-RAM or CG-RAM. When address information is written into the IR, data is read and then stored into the DR from DD-RAM or CG-RAM by an internal operation. Data transfer between the MPU is then completed when the MPU reads the DR. After the read, data in DD-RAM or CG-RAM at the next address is sent to the DR for the next read from the MPU. By the register selector RS signal, these two registers can be selected. Table 1. Busy flag. When the busy flag is 1, the HD44780U is in the internal operation mode, and the next instruction will not be accepted. When RS equals 0 and RW equals 1, table 1, the busy flag is output to DB7. The next instruction must be written after, ensuring that the busy flag is 0. address counter AC. The address counter AC assigns addresses to both DDRAM and CGRAM. When an address of an instruction is written into the IR, the address information is sent from the IR to the AC. Selection of either DDRAM or CGRAM is also determined concurrently by the instruction. After writing into, reading from DDRAM or CGRAM, the AC is automatically incremented by 1, decremented by 1. The AC contents are then output to DB0 to DB6 when RS equals 0 and RW equals 1. Table 1. Table 1, register selection. RS 0 when RW is 0 also. Operation. IR, write as an internal operation, display, clear, etc. So when RS is 0 and RW is 1, read busy flag DB7 and address counter DB0 to DB6. When RS is 1 and RW is 0, DR write as an internal operation DR to DDRAM or CGRAM. When RS is 1 and RW is 1, DR read as an internal operation DDRAM or CGRAM to DR. Display data RAM, DDRAM. Display data RAM, DDRAM stores display data represented in 8-bit character codes. Its extended capacity is 80 by 8 bits or 80 characters. The area in display data RAM, DDRAM, that is not used for display can be used as general data RAM. See Figure 1 for the relationships between DDRAM addresses and positions on the liquid crystal display. The DDRAM address ADD is set in the address counter AC as hexadecimal. 1 line display n equals 0. Figure 2. When there are fewer than 80 display characters, the display begins at the head position. For example, if using only the HD44780, 8 characters are displayed. See Figure 3. When the display shift operation is performed, the DDRAM address shifts. See Figure 3. AC hexadecimal, high order bits, low order bits. High order bits are AC6, and there's 3 of them, to AC4. Low order bits are AC3, 2, 1, and 0. Example DDRAM address for E 1001110. Figure 1. DDRAM address. Display position digit. DDRAM address hexadecimal. 1 to 5 to 79 to 80, 00, 01, 02, 03, etc. Maybe that's hexadecimal. Figure 2. One line display. Display position, DDRAM address, 00 up to 07. For shift left, thus. For shift right, thus. Figure 3. One line by 8 character display example. 2 line display, n equals 1, Figure 4. Case 1. When the number of display characters is less than 40 by 2 lines, the 2 lines are displayed from the head. Note that the first line, end address, and the second line, start address, are not consecutive. For example, when just the HD44780 is used, 8 characters by 2 lines are displayed. See Figure 5. When display shift operation is performed, the DDRAM address shifts. See Figure 5. Display position, DDRAM address hexadecimal. Thus, Figure 4, display position, DDRAM address, 4 shift left, 4 shift right. Figure 5, 2-line by 8-character display example. Case 2, for a 16-character by 2 display, the HD44780 can be extended using 140 output extension driver. See Figure 6. When display shift operation is performed, the DDRAM address shifts. See Figure 6. Display position, DDRAM address. HD44780U display, extension driver display. 4 shift left, 4 shift right. 2-line by 16-character display example. Character generator ROM, CG-ROM. The character generator ROM generates 5x8 dot or 5x10 dot character patterns from 8-bit character codes. Table 4. It can generate 208 5x8 dot character patterns and 32 5 times 10 dot character patterns. User-defined character patterns are also available by mask-programmed ROM. Character generator RAM, CG-RAM. In the character generator RAM, the user can rewrite character patterns by program. For 5x8 dots, 8 character patterns can be written, and for 5x10 dots, 4 character patterns can be written. Write into DDRAM the character code at the addresses shown as the left column of Table 4 to show the character patterns stored in CG-RAM. See Table 5 for the relationship between CG-RAM addresses and data and display patterns. Areas that are not used for display can be used as general data RAM. Modifying character patterns. Character pattern development procedure. The following operations correspond to the numbers listed in Figure 7. Determine the correspondence between character codes and character patterns. Create a listing indicating the correspondence between EEPROM addresses and data. Program the character patterns into the EEPROM. Send the EEPROM to Hitachi. Computer processing on the EEPROM is performed at Hitachi to create a character pattern listing, which is sent to the user. Number 6. If there are no problems within the character pattern listing, a trial LSI is created at Hitachi and samples are sent to the user for evaluation. When it is confirmed by the user that the character patterns are correctly written, mass production of the LS1 proceeds at Hitachi. I'll try and zoom out. So here's a flow chart. Note, for a description of the numbers used in this figure, refer to preceding page. So I guess I'll start at the user. User start. Determine character patterns. Create EEPROM address data listing. Write EEPROM to Hitachi. 1, 2, 3, 4. And I guess then it flows up here. Computer processing. Create character pattern listing. Evaluate character patterns. Okay, yes. Artwork, MT, masking, trial, sample evaluation. Okay. Mass production. Don't quite understand what it's talking about when it says mass production. Programming character patterns. This section explains the correspondence between addresses and data used to program character patterns in EEPROM. The HD44780U character generator ROM can generate 208 5x8 dot character patterns and 32 5x10 dot character patterns for a total of 240 different character patterns. EEPROM address, data, and character pattern data correspond with each other to form a 5x8 or 5x10 dot character pattern table 2 and 3. Example of correspondence between EEPROM address data and character pattern 5x8 dots EEPROM. A11 down to A0. Data combinations 04 down to 00 as the least significant bit. Combinations of zeros and ones. Okay. Cursor position. Character code. So this is the character code, I guess. Line position. Cursor position. Notes EEPROM addresses A11 to A4 correspond to a character code. EEPROM addresses A3 to A0 specify a line position of the character pattern. EEPROM data 04 to 00 correspond to character pattern data. Just zoom out, that makes more sense. EEPROM data 05 to 07 must be specified as 0. A lit display position black correspondence to a 1. Line 9 and the following lines must be blanked with zeros for a 5x8 dot character fonts. Handling unused character patterns. EEPROM data outside the character pattern area. Always input zeros. Number 2, EEPROM data in CGRAM area. Always input zeros. Input zeros to EEPROM address 00H to FFH. EEPROM data used when the user does not use any HD44780U character pattern according to the user application, handled in one of the two ways listed as follows. A. When unused character patterns are not programmed. If an unused character code is written into DDRAM, all its dots are lit, but not programming a character pattern, all of its bits become lit. This is due to the EEPROM being filled with ones after it is erased. When unused character patterns are programmed as zeros, nothing is displayed even if unused character codes are written into DDRAM. This is equivalent to a space. Table 3, example of correspondence between EEPROM address data and character pattern 5x10 dots. And I won't read all of this. Because I think it's probably similar to the 5x8 description above. So maybe I can pause it if I, for some reason, need to read that. And table 4, correspondence between character codes and character patterns. ROM code A00. Lower bits, upper 4 bits. I guess it's showing all the characters. Table 4, correspondence between character codes and character patterns. ROM code A02. Table 5, relationship between CGRAM addresses, character codes, DDRAM, and character patterns. CGRAM data. See, I really don't know what this is talking about yet, but I can see a letter R. And it's got some notes on all that. Relationship between CGRAM address character codes and character patterns. Timing generation circuit. Timing generation circuit. The timing generation circuit generates timing signals for the operation of internal circuits such as DDRAM, CG-ROM, and CG-RAM. RAM reads timing for display and internal operation. Timing by MPU access are generated separately to avoid interfering with each other. Therefore, when writing data to DDRAM, for example, there will be no undesirable interferences such as flickering in areas other than the display area. Liquid crystal display driver circuit. The liquid crystal display driver circuit consists of 16 common signal drivers and 40 segment signal drivers. When the character font and number of lines are selected by a program, the required common signal drivers automatically output drive waveforms, while the other common signal drivers continue to output non-selection waveforms. Sending serial data always starts at the display data character pattern corresponding to the last address of the display data RAM, DDRAM. Since serial data is latched when the display data character pattern corresponding to the starting address enters the internal shift register, the HD44780U drives from the head display. Cursor blink control circuit. The cursor blink control circuit generates the cursor or character blinking. The cursor or the blinking will appear with the digit located at the display data RAM, DDRAM address set in the address counter, AC. For example, figure 8, when the address counter is 08H, the cursor position is displayed at DDRAM, address 08H. Interfacing to the MPU. The HD44780U can send data in either two 4-bit operations or one 8-bit operation, thus allowing interfacing with 4 or 8-bit MPUs. For 4-bit interface data, only 4 bus lines DB4 to DB7 are used for transfer. Bus lines DB0 to DB3 are disabled. The data transfer between the HD44780U and the MPU is completed after the 4-bit data has been transferred twice. As for the order of data transfer, the 4 high-order bits for 8-bit operation DB4 to DB7 are transferred before the 4 low-order bits for 8-bit operation DB0 to DB3. The busy flag must be checked one instruction after the 4-bit data has been transferred twice. 2 more 4-bit operations then transfer the busy flag and address counter data. For 8-bit interference data, all 8 bus lines DB0 to DB7 are used. RS, register select, low to high, I guess something's going on here as well. RW goes from low to high, and the enable bit, I don't know, is going low and high. And DB7, DB6, 5 and 4. Okay, this is a 4-bit transfer example. So I don't know, I can stop and pause that. Instruction register IR write, busy flag BF, and address counter AC read, data register DR read. Reset function, initializing by internal reset circuit. An internal reset circuit An internal reset circuit automatically initializes the HD44780U when the power is turned on. The following instructions are executed during the initialization. The busy flag BF is kept in the busy state until the initialization ends, BF equals 1. The busy state lasts for 10 milliseconds after VCC rises to 4.5 volts. Number 1, display clear. Number 2, function set DL equals 1 8-bit interface data, N equals 0, 1 line display, F equals 0, 5 by 8 dot character font. Number 3, display on off, D equals 0, display off, C equals 0, cursor off, B equals 0, blinking off. 4, entry mode set. ID equals 1, increment by 1, S equals 0, no shift. Note, if the electrical characteristics conditions listed under the table power supply conditions using internal reset circuits are not met, the internal reset circuit will not operate normally and will fail to initialize the HD44780U. For such a case, initialization must be performed by the MPU as explained in the section Initializing by Instruction. Instructions. Outline. Only the instruction register IR and the data register DR of the HD44780U can be controlled by the MPU. Before starting the internal operation of the HD44780U, control information is temporarily stored into these registers to allow interfacing with various MPUs which operate at different speeds, or various peripheral control devices. The internal operation of the HD44780U is determined by signals sent from the MPU. These signals, which include register selection signal RS, read, write signal RW, and the data bus DB0 to DB7, make up the HD44780U instructions. Table 6. There are 4 categories of instructions that designate HD44780U functions, such as display, format, data, length, etc. Set internal RAM addresses, perform data transfer with internal RAM, perform miscellaneous functions. Normally, instructions that perform data transfer with internal RAM are used the most. However, auto-incrementation by 1 or auto-decrementation by 1 of internal HD44780U RAM addresses after each data write can lighten the program load of the MPU. Since the display shift instruction table 11 can perform concurrently with display data write, the user can minimize system development time with maximum programming efficiency. When an instruction is being executed for internal operation, no instruction other than the busy flag address read instruction can be executed. Because the busy flag is set to 1 while an instruction is being executed, check it to make sure it is 0 before sending another instruction from the MPU. Be sure the HD44780U is not in the busy state, BF equals 0, before sending an instruction from the MPU to the HD44780U. If an instruction is sent without checking the busy flag, the time between the first instruction and next instruction will take much longer than the instruction time itself. Refer to Table 6 for the list of each instruction execution time. Instructions. Clear display, return home, entry mode set, display on-off control, cursor or shift display, function set, set CG-RAM address, set DD-RAM address, read busy So yes, I guess I'm skipping the description. I guess I can pause and read that if I want. Instruction, is this just a continuation? Yeah. Write data to CG or DD RAM. Write data from CG or DD RAM. Yeah, I'm losing steam here. Oh well. Instruction description. Clear display. It gives an elaboration of each of the above. Clear display writes. Yeah, I'm tired.